In this topic, we're going to look at functions and relations. We're going to identify relations. We're going to look at how to identify functions using the input and output, and we're going to also examine the vertical line test for functions. Now, a relation expresses a relationship between two variables. The input variable or the starting variable is called x. The end points or the ending variables are called the output variables. Now, the other thing to note here is that your x variable is also called your independent variable because it's your input, and your output is also called your dependent variable because its value is affected by the input variable or the independent variable. Now let's look at functions. A function is a relation that satisfies the following conditions. Every input must have exactly one output. So that means the domain value must always have one range value. Your domain is the same as your input. So if you had an axis that looked like this right here, your horizontal line represents your x, your vertical line represents your y. All the points on the x line on the x-axis are called input values, or we can call them domain values. All the values on the y are called output values, or we can call them range values. Now what we're saying here is that each domain value must have only one range value, but it's also possible that multiple domain values can point to the same range value. And one thing to note here is that all functions express a relationship between variables, but not all relations fulfill the requirements to be considered as functions. Now let's look at this and see if we can identify the ones that are functions and the ones that are not functions. So we start with these, let's call this A, B, C, and D. Let's start with A. So remember, every domain value must have exactly one range value. So let's see. 4 has 1. So if we look through here, we can see that every domain value points to only one range value. Now, so this will be considered a function. Let's look at B. Every domain value must have only one range value. So we can see here, if you look at 2 and 4, 2 and 4 point to the same range value. This is valid because they are unique values on the domain that points to a value on the range. Now we look at C, we can see that -4, -3, 0, 1, 2 points to -8 as the range value. This is also valid right here because each of the domain values points to just one range value. So this is a function. Now, let's look at this function here, this relationship here, and see if it's the relationship represents a function. So we can see that 4, 3, 0, 1, they point to one domain, they point to one value on the range, which is the y. Now let's look at 2. 2 points to both 12 and 15. For that reason alone, this is not a function because you can only have one domain value and one range value. So we call that an ordered pair. So that is why that is not a function, because 2 points to 12, it also points to 15 on the range. Now let's see if we can get it from the ordered pairs. So here we have, I'm going to write it as x and y. It makes it a lot easier to see. We have 3, -3, and 4 here. We have 4 and 2. We have 6 and 7. We have 8 and 9. We have 9 and 0. You can see here that the domain values point to exactly one range value. There's no repeated range value for any domain. So let's look at B. We have x, y here. We have -8 to -3, -6 to -3, 0 to -3, 4 to -3, and then 5, and then we have -3. So what you can see here is that your range values are repeated, but you don't have your domain value point to two different range values. So for that alone, this is a function, and A is also a function. Now let's look at C. We put our x and our y here. We have -1 and 6, 0 and 3, 2 and 4, 3 and 4, -1 and 3. So you can see -1 is repeated. If it's repeated, you must have the same y value if it's a function. But you can see here that we have two different range values, two different y values for the same domain value. So this is not a function. Now let's look at these tables and see if we can identify the ones that are functions and the ones that are not functions. So for it to be a function, each of the domain values must have only one range value. So if we look at this table, let's call this table A, let's call this one B, let's call this C, and let's call this D. So table A, you can see that each of the domain values have only one range value. So we'll call this a function. Table B, we can see the domain values are, you see, -3 and -3, but they have two different range values. So this is not a function. Let's look at table C. We have -1, 2, 3, 4, 5, 7, but they all point to the same range value. So this is a function. And then table D, we have -1, 2, 3, 4, 5, 7. And in this case, the x is not repeated, so we have them pointing to unique range values. So this is called a function. Now let's look at the vertical line test. The vertical line test just tells us that for any graph, any function or any relation that is represented as a graph, if we draw a vertical line at any point of the graph, for it to be a function, the vertical line can only touch or intersect the graph at only one point. Now let's look at some examples there. So we're going to use the vertical line test to determine if this graph represents a function. So I put a line right here, I put a vertical line right here. I can see that it intersects at only one point, so this is a function. I draw a vertical line right here and I draw another vertical line right here. It only touches the graph at one point, so this is a function. What about with this graph here? If I draw a line right about here and right about here, you can see that each time the vertical line only touches the graph at one point, so this is a function. And then finally, let's draw a vertical line here. Oh, we have 2 points right here on this graph. What about right here? We have 2 points again over here. So this is not a function. So these are the different ways we can identify functions and relations when you have a set of or a distribution of numbers or a distribution of input-output values.